Hi everyone, in this video we are going to discuss about what is the necessary condition for two straight lines to be perpendicular with each other. So here in this diagram I have two straight lines L1 and L2. Those are the two straight lines. Let's assume that they are in a perpendicular position with each other, right? So then angle ACB would be 90 degree, and also let's assume that the equation of the line L1 is y equals m sub 1 times x plus c sub 1, and similarly let's assume that the equation of the line L2 is y equals m sub 2 times x plus c sub 2. Let's assume that the line L1 makes an angle alpha with the positive x-axis, and also let's assume that the line L2 makes an angle theta with the positive x-axis. So now let's calculate the value of theta in terms of alpha. Now can we write it like this? If you look at the little triangle ABC, it's actually a right triangle where the right angle is the angle ACB and also the angle CAB, that is alpha. So what will be the value of angle ABC? Well, angle ABC will definitely be 90 degree minus alpha. Now let's look at the theta angle. So can we say theta plus angle ABC is equal to 180 degree, because that would be a straight angle. So from here let's substitute the value of angle ABC in terms of alpha. So from here we can say, so I have simply replaced the value of angle ABC with the 90 degree minus alpha. That was the value of angle ABC that we derived just in the above line, right? Let's now try to find out what is the value of theta. So we get the value of theta in terms of alpha as 90 degree plus alpha, right? So let me write it down here. Now let's try to find the slope of each of the lines. So for the first line L1, can we say that m sub 1 would be equal to tangent of alpha, because that will be the slope of that straight line? And similarly, can we also say that for the line L2, m sub 2, which is the slope of that line, m sub 2 would be tangent of theta? And then let's use the value of theta in terms of alpha. So that will be equal to tangent of 90 degree plus alpha, and tangent of 90 degree plus alpha would be equal to negative cotangent of alpha. I have already created a video on trigonometric ratios of such obtuse angles. Feel free to watch that video. I will post the link in the description. So in that video you will see that the value of tangent of 90 degree plus alpha is actually equal to negative cotangent of alpha. So here we can write negative cotangent of alpha. Now let's multiply m sub 1 with m sub 2 and see what happens. So that will be equal to tangent of alpha for m sub 1 times, for m sub 2 we can write negative cotangent of alpha, and then if we simplify a little bit, so tangent of alpha, let's keep it as is, times it would be negative 1 divided by tangent of alpha, because cotangent is the reciprocal of tangent, so we can write cotangent as 1 over tangent. So negative cotangent alpha would be negative 1 divided by tangent of alpha, and from here we see that this tangent of alpha and this tangent of alpha will cancel each other. So now we are going to be left with a value of negative 1. So from here we can say that there is one relationship, which is m sub 1 times m sub 2 would be equal to negative 1, and that is the required condition for the two lines to be perpendicular with each other. Now let's take an example. Suppose we have two straight lines whose equations are like this. Here in the equation for the second straight line, I have introduced an unknown variable k. So there the equation is like k times x minus 3y is equal to 1. That is the equation of the second straight line in our example, and the equation of the first straight line is 2 times x plus 3 times y is equal to 5. So the question here is, what should be the value of k for which these two straight lines will be perpendicular with each other? So let's try to find the slope of each of the lines. Let's try to write the first equation like this. So from here, can we say it like this? And then if we divide both sides by positive 3, then this is what we are going to get. And from here, let's try to rearrange this little bit. So finally, we can see that the slope of the first straight line is actually negative 2y3, because we have rewritten the equation in form of y equals mx plus c. So here m is actually negative 2/3. That's the slope of the first straight line. Now let's do the similar thing for the second straight line. So I'm going to write it right here. For the second straight line, we can say, okay, this is kx minus 3y is equal to 1. And then let's try to keep 3y on one side, and we're going to get something like this. And then if we divide both sides by positive 3, we're going to get something like that. And here you can clearly see that the slope of the second straight line is actually k divided by 3. Now from our theorem, we know that for two straight lines to be perpendicular with each other, the product of their slopes should be equal to negative 1. right, which you can see up above there. m1 times m2 should be equal to -1. So we are going to use the same theory here. So now that we know the slopes of both of the straight lines, so we can designate the slope of the first straight line as m sub 1, and then we can designate the slope of the second straight line as m sub 2. So here let's use the same theorem that m sub 1 times m sub 2 must be equal to -1. Now let's substitute the values here. What is m sub 1? That is -2/3. And what is m sub 2? That is k divided by 3, and all of that should be equal to -1. And then from here let's try to do some simplification here. So this is actually -2 divided by 9 times k on the left hand side, and the right hand side is still -1. And if we multiply both sides by -1, then we are going to get 2 divided by 9 times k is equal to 1. And then from here we are going to get k equals 9 divided by 2, and that is the necessary value of k for which these two straight lines will be perpendicular with each other. I hope everything made sense. Thank you for watching. See you in the next video.